Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Okay, berjumpa lagi kita. So, welcome back to our next session. This session we will continue with whatever that we have left before. So, last time we have looked through mainly all of the topics under chapter 4, and we still left with one more topics. So this will be the last topic for chapter 4 before we move to the last chapter, that is chapter 5, bivariate analysis. Okay, so going back to what we have just learned previously, so we have gone through all the hypothesis testing included in chapter 4, whereby we have looked through the one sample t-test, the independent sample t-test. We also have looked through the dependent sample t-test, or sometimes called as the paired sample t-test. And last week we have go through testing for more than 2 means. Okay, for more than 2 means, whereby we are using ANOVA to test the difference between more than 2 means value. Okay, so for this time right now, we are going to continue with our last topic in chapter 4. So ini adalah topik yang terakhir dalam chapter 4, that is chi-square test of independence. Okay, if you go through your textbooks, okay, not your manual, because the manual has been customized according to the syllabus. If you go through the textbook that I have provided you, the Alan G. Blumen, so kalau tengok dalam buku Alan G. Blumen tu ada topik chi-square test, chi-square test of independence. So in the same chapter there is another testing procedure. We call that as test for goodness of fits. Okay, please discard this from your readings, because that one is not included in our syllabus. Okay, so yang tu tak masuk dalam syllabus kita. So yang tu you all boleh buang lah so daripada penggunaan Alright, so we're going to continue with chi-square test of independence. So what is actually chi-square test of independence? Okay, bear in mind, for your information, this slide is already on the website, so you can just go to the if you want to go through the slide with me, you can just go to the URL. Okay, so the URL is just simply, kalau tengok kat sini, let me just glance through this one. So you can just go to, okay, so you boleh pergi kat sini lah. So this is the you can go to arif118.github.io. okay, depannya sama je macam saya punya website, and then slash chi dash square dash notes. Okay, so saya akan sharekan this link in the chat section, nanti you all boleh tengok lah. Okay, let me just share this link in the chat section. Sebentar saya pergi dekat chat. Okay, boleh dapat dekat chat section tu saya dah share the link for the website, so you can browse through the website through your mobile phone or also maybe through your laptop. But if you are using the Google Meet right now, you can just go through to the Google Meets. Alright, so hopefully you can see the screen. Okay, without further ado, let's just continue with the topic of chi-square test of independence. Okay, actually, what is chi-square test of dependence? So in this situation, chi-square test is the single most frequently used test of hypothesis in social sciences. So this is common test used by the social sciences people, because normally when they have the social sciences people doing research, they will just gathering information on count data. Okay, gathering information on count data. So since one of the reason to use chi-square in this situation is that the data that has been collected is in the form of count data, and this is a non-parametric test whereby you don't need any assumption. You don't need rigid assumption in order to make the result valid. Okay, so that is one of the reason kita gunakan chi-square test lah. Okay. So this is one of the common tests used in the social sciences and also in the medical field. So they also use chi-square test most of the time in checking or in testing the hypothesis to see whether is there any relationship between two variables or not. Okay. Okay, it is a non-parametric test, so requires no assumption. So bila katakan non-parametric ni, it requires no assumption. Berbanding dengan hypothesis yang sebelum ni, so berbanding dengan referring to the previous material that we have covered, the independent sample t-test, the paired sample t-test, the ANOVA, all those testing that we have done previously is a parametric test, whereby it has a very rigid assumption to be made in order for the result to be valid. Okay, so that the result be valid, and also whenever you convey the information to the audience, it is not a misleading information. Okay, so that means even so in that particular situation, if you have violated certain assumption, then even though you can get the result from the parametric test, but the result is misleading, is not valid. So you cannot make a generalization based on that particular result. So that is the situation, and that is why we sometimes people go for the non-parametric test, whereby there is no assumption in terms of running the analysis. However, in terms of the power of doing prediction, it is less powerful compared to the parametric test. Okay, so that is one of the things that you need to understand. Okay, again, one more thing is that it is appropriate for normally measured variables. Okay, so for normally measured variables in parametric test, if you have a normally measured variables, the testing procedure are limited. Okay, the testing procedure are limited. You cannot do any kind of you cannot just simply take any parametric test for the nominal data. So that will be a problem. So that's why for nominal measured variables, so we go for the non-parametric. Okay, so non-parametric macam ni lah, chi-square test. Of course, there are other non-parametric test. So yang tu kita tak masuk dalam kita punya syllabus. Alright. Okay, boleh follow Alright. So can be used in two sample case, but can also be used where there are more than two samples. So in our station, we are looking at two sample case. Bila kita kata two sample case ni, maksudnya a two-way table, that is two variable involved. Okay, so in our syllabus, we only considering the two sample case. We are not going to look on the more than two sample. Okay, so that is the situation for our syllabus. So kita takkan tengok yang three-way table, kita takkan tengok. So we only look into the two-way table only. Okay, two-way table maksudnya kat sini adalah dalam bentuk hanya ada dua variable involved. And of course, for each of the variable, they have more than 2 levels. Okay, at least 2 So at least 2 levels. So 2 level ni maksudnya categories within the variable itself or within the category itself. Okay. Okay, the logic of chi-square, the chi-square test for independence. First, that two variables are independent if, for all cases in the sample, the classification of a case into a particular category of one variable has no effect on the probability that the case will fall into any particular category of the second variable. So, apa yang dimaksudkan kat sini, so panjang dia, ayat dia, yang dimaksudkan kat sini adalah, when we classify into one variable, okay, category into one variable, it do not affect the probability that the case will also fall in a particular category in the second variable. Okay, dia tak kata, okay, kalau katakan, let's say, in this situation, let's say you have a two-way table. Okay, let's say you have a two-way table. Suppose that a case falls in here. Okay, dalam untuk yang satu, katakan this is A, and this is a complement of A, and this is B, and this will be a complement of B. Okay, so in this situation, when we talk about this one, so suppose that it falls under A. It doesn't show that for category B, it must also fall under B. Okay, itu yang dimaksudkan. It doesn't affect that it will fall in B. It doesn't affect the probability that it fall in B. For example, let's say 60% of cases go to A. Okay, 60% of the cases go to category A. And then 40% of the cases go to category A prime. So, apa yang dimaksudkan sini? Kalau katakan 60%, it doesn't say that, kalau katakan, it must also go to 60% on category B. Okay, itu yang dimaksudkan. So, dia tidak akan affect dia punya probability. 60% also must be in B. No. So, they are independent of each other. It can go anywhere. Okay, in the cells. So, itu yang dimaksudkan dengan they are independent of each other. Okay, so that is the first one. Okay, and then the second one, to conduct a chi-square test, the variable must first be organized into a bivariate table. So another name for the bivariate table is contingency table. Pernah dengar kan ini? So we have deal with this one in chapter 2. Okay, we have deal with this one in chapter 2, bivariate table or contingency table. Kenapa kat sini disebutkan bivariate table? Because in this situation, we are only looking at two variables at a time. Okay, so in our syllabus, we are only looking at two variables. So that's why we call this as a bivariate table, because it is a two-dimensional table where you have two variables only. Okay, or sometimes we call this as a contingency table. And remember, contingency table, you can also have two-way, three-way, or four-way. So, but in our syllabus, we are only considering the two-way table. So, this is what we are doing in these chapters, okay, in this topic. So, kita tak akan tengok yang lebih daripada tu, Okay. So, what is bivariate table actually? Okay, later on we're going to see that in more detail. So, a contingency table is used to investigate whether two traits or characteristics are related. Okay, two traits or characteristics ni lebih kepada dalam social sciences ataupun in psychological punya study. So, that's why saya katakan tadi, the chi-square test is most commonly used in social sciences research. Okay. So, two traits are characteristics are related. Each observation is classified according to two criteria. Okay, so according to two criteria. So kita akan tengok in detail what does this means. Okay, before we go into detail what are bivariate tables, okay, how the bivariate tables relate to the chi-square test of independence. So let's look at what are the requirements for your data. Okay, requirement for your data in order to run chi-square test of independence. Okay, so your data must meet the following requirements. The first one is two categorical variables. Okay, sebab kita consider dua kat sini. So you must have two categorical variables. So at least two. Tak boleh kurang daripada dua. Satu tak boleh buat. So if you have only one categorical variable, that will be falls under the topics yang kita tak masuk dalam syllabus. That is, you can do chi-square test for goodness of fits. Okay, so you can use goodness of fit test using chi-square. So yang tu for one variable. Tapi for this situation, for the chi-square test of independent, of course you need two categorical variable. And in this case, it mentioned clearly categorical variables. Okay, so in this situation, meaning to say that you cannot use for numerical variables. So it must be in the form of categorical. If you have a numeric variable, then you have to convert it into categories. Okay. Second, two or more categories group for each variable. So apa yang dimasukkan sini? Under the categorical variables, for each of the categorical variable, it has two or more levels. For example, suppose that you have gender. Okay, your first letter is gender. For example, you have gender. Okay, this is your variable. Okay, so under gender, you have two categories or groups, right? So you have male or female. Okay, this is what it means by two or more categories. So in this situation, for each of the categorical variable that we are considering, you must have at least two. Can it be more than two? Yes. Sebab dia katakan two or more categories. Okay. So that is for the second one. Okay. Any questions so far? Ada? Okay, the third one is the data must be independent of the observation. So, ini macam tadi saya katakan. So, it must be independent of observation. What does this mean? There is no relationship between the subject in each group. So, between the subject itself, there is no relationship, right? And then, the categorical variable are not paired in any way. So, dia bukanlah dalam bentuk pairing. Dia bukan dalam bentuk dependent samples. Okay, dia bukan dalam bentuk dependent sample. Contohnya, you tak boleh ada data yang berbentuk pre-test and post-test. This is dependent sample. This is not independent because they have relationship. For example, in pre-test and post-test observation, the score come from the same element. Okay, kalau kita ada pre-test dengan post-test score of an exam, that means that particular score is from the same person. So this is considered to be having a relationship dependent observation. So we cannot have that. So in this situation, your data must have independent observation. Okay. And then relatively large sample size. So normally we are considering a large sample size situation. Kenapa So, kenapa perlu adanya large sample size? Kenapa tak boleh guna untuk yang small sample size? Okay. So, kalau large sample size tu normally kalau considered in a statistic, the number that considered as large is 30. Okay, but in this situation maybe more. Alright. So, one of the reasons is that the expected frequency for each cells are at least 1. So, later on we're going to look at what it means by expected frequency. Okay. So, if for each cell are at least 1. So, maknanya setiap sel mesti ada sekurang-kurangnya 1 bagi nilai expected frequency. So if you want 1 to be expected frequency, to a minimum of value 1 for the expected frequency, of course there shouldn't be any 0 in the observation. So maksudnya bagi data yang kita ada tak boleh ada count of 0. Because if you have a count of 0, that means maybe you can have a expected frequency of less than 1 or maybe 0. Okay. And then the second one, expected frequency should be at least 5 for the majority, 80% of the cells. So this is the assumption. So this is the only assumption that you must have in order to make sure that your data or your analysis is valid. Okay. So your expected frequency, the total expected frequency shouldn't be less than 5. If you have the expected frequency to be less than 5, the total amount shouldn't be more than 20%. Okay, the total amount shouldn't be more than 20%. So maknanya kat sini yang 80% ni maksudnya 80% daripada keseluruhan cells mestilah mempunyai sekurang-kurangnya 5 untuk nilai expected frequency. Itu yang dimaksudkan. So maknanya kalau ada yang kurang daripada 5 tu, paling maksimum tu dia boleh adalah 20% daripada total cells. Right? So that is the data requirement. Apa yang perlu ada. Okay. Okay, let's see what are the application of chi-square test of independence. So these are some of the situation where you can use chi-square test of independence. We can use the chi-square test statistic to formally test for a relationship, or we can also say in the form of association. Okay, either relationship or association. Okay, you boleh juga buat dalam bentuk association. Nampak tak Nampak Okay, so either in the form of relationship, or you can also use the term association. Okay, and then sometimes also we use the term independent or not independent. So in this case, we can use the chi-square statistic to formally test for an association or relationship between two nominal scale variables. So this is very important. Nominal scale variables. Okay. Can we use ordinal? The answer is yes, but rarely being used. Okay. But rarely being used. Boleh guna, tapi jarang sekali lah digunakan. Kebiasaannya kita gunakan nominal scale variables. Okay, to put it another way, is one variable independent of the other. So kita tengok adakah satu variable tu independent of the other variable. Sebab kita ada dua variable kan. So this is an example in situation 1. You have Ford Motor Company runs an assembly plant in Dearborn, Michigan. Okay, in Dearborn, Michigan, the plant operates 3 shifts per day. So you have 3 shifts per day. Okay, 3 shifts per day, 5 days a week. The quality control managers wishes to compare the quality level of the 3 shifts. So nak tengok ada 3 shifts. So maksudnya ada 3 kategori kat sini. Vehicles are classified by quality level, acceptable, unacceptable, and shift day, afternoon, and night. So in this situation, you can see that you have 2 variables. What are the variables? The first variable is quality. Okay, this is number 1. And then the second variable is the shift. So this is number 2, right? Okay, and then in each of the variable, for the first variable quality level, you have 2 categories, acceptable and unacceptable. Meanwhile, for the shift, you have 3 categories, day, afternoon, and night. Okay, so this meet the first assumption tadi kan, yang kita tengok tadi. Kalau perhatikan balik, if you go back to this first one, you have two categorical variable. Yes, you have two categorical variable. Two or more categories group for each variable. Yes, you have that. Independent observation. Yes, you have also independent observation. Relatively large size, so we're gonna look that. Of course, normally we have a relatively large size, large sample size. So the situation right now is there a difference in the quality level on the three shifts. So itu yang nak tengok, ada tak perkaitan quality level dengan shift. That is the quality of the product related to the shift when it was manufactured. So dia nak tengok adakah kualiti produk tersebut bergantung pada bila dia produce. Adakah the day shift produce a better product compared to afternoon shift. Okay, so in this situation dia nak tengok ada tak quality level bergantung ataupun dependent on the shift. Right, so that is the situation. Or you can just say that is the quality of the product independent of the shift. Okay, is the quality of the product independent of the shift. Okay, boleh juga Okay, and then the second situation, a sample of 100 drivers who were stopped for speeding violation was classified by gender. So you ada the first variable here, gender, and whether or not the drivers wearing seatbelt when stopped. So dia ada dua kat sini kan. So whether they wear seatbelt or do not wear seatbelt. So for this example, you have the association. You are looking for the association between wearing seatbelt and gender. Okay, so you're looking at wearing seatbelt to gender. So in this situation, you're gonna say maybe you're gonna look at whether a female more prone to not wearing a seatbelt compared to male driver. Okay, so that is the situation. Alright, so that is for the second one. The third situation give you this information. Does a male released from federal prison make a different adjustment to civilian life if he returns to his hometown or if he goes elsewhere to live? Okay, the two variables are adjustment to civilian life and place of residence. So adjustment to civilian life mungkin adalah dia punya criteria. Okay, and then place of residence tadi ada dua kan, sama ada dia go to his hometown, return to his hometown, or go as well. So ada dua kategori kat situ. Alright, so note that both variables are measured on the nominal scale. So this is the three example, the three situation whereby you can apply chi-square test of independence. Okay, any questions so far? Okay. Okay, what is bivariate table? So the idea of independence can be seen in bivariate or aka also known as the contingency table. So kita tengok satu persatu apa yang masukkan bivariate table. Of course you already know this. So bivariate table display joint classification of the cases on two variables. So joint classification. So apa yang masukkan dengan joint classification, dia joint. So maksudnya kalau katakan kita ada dua variables, okay, suppose that you have two variables and then you have two categories. So this is what we call as the joint classification, the cell inside here. Okay, so ini yang dimasukkan dengan joint classification. So apa yang dimasukkan dengan joint classification? So let's say this is A and B. So this part is actually a joint for A and B. So kita join A dengan B. So itu yang dimasukkan dengan joint classification. Right? The categories of independent variable are used as column holding. So this is the common practice. Okay, so normally the independent variable, we use the categories in the column heading. So you put it in the column headings. So column headings yang mana? Kalau column headings yang tadi itulah. Okay, kita ada column and row. So this is the column heading. So normally the column headings will be the independent variables. Meanwhile, the categories of the independent variable are used as the row heading. So in this situation, kalau kita tengok, the row headings will be something like this lah. So this will be the row headings. Okay. So that is the position in the bivariate table on the independent and dependent variables. And then the marginal are the univariate frequency distribution for each variables. Okay, apa tu marginal? So kalau katakan marginal ni, this is normally being the term is normally being used in statistics, marginal probability, marginal values, and so on. Okay, right? But in layman people, what does this mean? So actually, the simplest form to understand what is marginal means is just simply the word total. Okay, so the marginal values in this situation for the bivariate table is just simply the total values for the rows and column. Okay, the total values for the rows and column. So in this situation, kalau you dapat kat sini, okay, this is, let's say, two-way table. So the value over here, okay, this is what we call as the marginal. Okay, this is what we call as the marginal value, or in probability, we call this as a marginal probability. Yang dalam ni tadi kita panggil apa? Joint classification. So we have the joint probability. So inside the cell is joint classification. Outside is the total. We call it as marginal. Okay. Okay, next, to find the number of cells in a table, you have to multiply the number of categories of the independent variable by the number of categories in the dependent variable. So for example, in this case, if you have independent variable, you have two categories. And then you have dependent variable, suppose you have three categories. So in order to find the number of cells, you just need to multiply the number of categories. So you have 2 times 3 is equal to 6. So you know that you're going to have 6 cells. Where does these 6 cells come from? Again, you have the independent variable, 2 categories. Sorry. Oh, ni independent variable 3. Siap. Saya pandang boleh. Okay, suppose that you have this thing. Okay, dia kata di sini dia ada, tadi kita nakkan 2 dengan 3 kan. So you have the independent variable 2 and then the dependent variable 3, right? So this is 1 and 2 for the independent variable, and this is for the dependent variable 1, 2, 3, the 3 categories. So you multiply 1 and 2 and 3, you get 6. So you have 6 cells over here. So itu yang dimaksudkan Okay, the multiply the number of categories of the independent variable and by the number of categories of the dependent variable. So you get the number of cells. So in this case, you have 6 cells, for example. Okay. And then a bivariate table in which both variables have 3 categories has 9 cells. So macam tadi lah. Okay, sebab kita ada kalau 3 categories, so 3 times 3, so you get 9 cells. Okay, so maknanya akan ada 9 lah. Okay, ada 9 cells dekat dalam tu. If 2 variables are independent, the cell frequency will be determined by random chance. So apa yang dimaksudkan di sini? Kalau katakan 2 variable tersebut ada independent, the value inside the cell is by random. Okay, it's by random chance if they are independent. Okay. Okay, the null hypothesis state the variables are independent. So in chi-square test, the null hypothesis always state that the variables are independent. Or another terms that we can use is no association, or maybe no relationship, ataupun not related ataupun no relationship, boleh juga, tak ada masalah. Okay, so that is for the null hypothesis. So always remember that. So the null hypothesis is whether there are independent, no association, or no relationship. The null hypothesis is true. The expected cell frequency are what we would expect to find on the random chance were operating. So yang ni tak ada apa lah. Okay, the actual frequency would differ little from the expected frequency. Okay, ini kalau sekiranya null hypothesis is true. When you calculate the expected frequency value shouldn't be too far away from the actual frequency. Okay, the actual frequency dengan expected frequency shouldn't be differ too much. Okay, nanti kita akan tengok macam mana nak kira expected frequency. Therefore, it is still the hypothesis of no difference, but this time the difference measured is between the observed frequency and the expected frequency. So, itu bezanya dengan parametric test. So, parametric test, we are comparing if there exists any difference or not between two mean value, right? But in this situation right now, we are not testing between two values, okay? But we are testing between the observed and the expected frequency. We are not testing on the mean for gender, for example, with mean for smoking habit. Kita tak buat macam tu sebab in this station, again, you know that this value or this bivariate table is consisting of nominal level data. So nominal level data cannot be calculated or cannot be interpreted using numerical values. So tak boleh. So kita tak boleh katakan, okay, mean gender adalah 1.3. No, you cannot do that. Even though you are using coding 1 and 2 and you can calculate the average, but the average is meaningless because they are nominal level of measurement. So nominal level of measurement, you cannot have a numerical measures to summarize the actual information. Okay, so that is the situation. Okay, when the variables are independent of each other, there should be little difference between the observed frequency and the expected frequency. Okay, ini dia punya key idea. So nanti kita akan tengok dari segi pengiraan. Okay, macam saya katakan tadi, kalau katakan they are independent between observed dengan expected frequency, dia tidak adalah banyak perbezaan. Kalau banyak perbezaan tu, kita boleh katakan yang dia adalah dependence. Okay, this slight difference would be due to chance alone. If the null is false, we reject the null. There should be a large difference between the two. So, kalau kita nak reject null hypothesis, katakan dia adalah dependent. Okay, to conclude that the both variables are dependent. So, you must show that the difference between the two variables, that means the observed and the expected frequency, the difference are large. Okay. So, in terms of running the analysis for the chi-square test of independent, you need to compute the test statistic. Okay, so this is the procedure. Of course, if you look through back what we have learned before, whenever you want to test a hypothesis, kita ada 5 step kan? We have 5 step. So we have the first state the hypothesis, and then you find the critical value, then you find the test value, and then make your decision, and lastly make your conclusion. The same thing goes here, cuma saya tak letak yang the first one tu hypothesis tu So in order to test your data using chi-square test of independent, you need to find the chi-square test value, or this is called the chi-square test statistic value, and you have to find this using a formula. Later on we're going to see the formula. Next, you have to find the chi-square critical value, and this can be found from the statistical tables. Okay, chi-square statistical tables. Okay, the chi-square critical value is found by looking in the chi-square table. Refer to your statistical table for a particular alpha level and degrees of freedom. Again, you can ada dua benda lah. So in this case, you have the alpha level and the degrees of freedom. So you have to find the value of chi-square with alpha and degrees of freedom, so equal to 1. So this is from table. Okay, this is from table. Okay, and then the degrees of freedom can be found by taking the number of rows minus 1 multiply the number of columns minus 1. Okay, for example, let's say you have a 3 by 2 bivariate tables. So in this case, this is the row, this is the column. Okay, so to find the degrees of freedom is just simply equal to 3 minus 1 times 2 minus 1. So you get this to be equal to 3 minus 1 is 2, 2 minus 1 is 1, right? So the degrees of freedom is 2. Okay, so that is how you find the degrees of freedom. Okay, any questions so far? Boleh? Boleh ke?
Boleh, sir.
Alright. Right, so the next one we're going to look at is the formula to calculate the chi-square test statistic. So the formula is given by this, the formula that you can see in front of you on your screen. So what does this mean? So you have O and E. So in this situation, the O refer to the observed frequency. Okay, so what is the observed frequency? So observed frequency is the frequency that you already have. Okay, and this one is you calculated from your sample, right? And then not calculate, you record from your sample. Okay, yang dah diberi. And E here refer to the expected frequency. Okay, so next slide we're going to see how we can calculate the expected frequency. But first, we are looking for the chi-square test statistic. So this is the formula that you can use to find the chi-square test statistic. So the formula tells you in order to calculate the chi-square test of statistic, you sum over all cells. Okay, sum over. So yang ni dia ada sum ni, sum over all cells. The square difference between the obtained value and the expected value. So obtained frequency and the expected frequency. So dia katakan the square difference. So that means you have to minus or take the difference between O and E first and then square them. Okay, next you have to divide by the expected frequency. So you have to square, take the difference and then square, then divide by the expected frequency for each cells. Then baru you sum. So baru you sum. Sebab dia kata sum over all cells. So kalau kita buat kat sini, kita kena buat kalau ada 4 sel. So mana ada, maknanya ada 4 lah. So kalau ada 4, let's say you have 2 by 2 table. So you have O11 minus E11 divided by E11 square yang ni. And then plus pula O12 plus E12 square divided by E12. And then plus another one, you have O21 minus E21 square divided by E21, and then plus another one. Lastly, you have O22 minus E22 square, and then divide by E22. Okay, so that is what it means over here. So you sum all of this. So ini katakan sum over all cells. So this is the first cell, this is the second cell. Okay, ini sel yang pertama, ini sel yang kedua, bagi 2 by 2. So this is sel yang ketiga, this is sel yang keempat. So that means sum over all 4 cells. The squared difference between the two obtained values. So yang ni ya, this part, the squared difference and then divided by the frequency yang bawah ni. Okay, so this is how you get the value for the chi-square test statistics. Okay. Okay, to find the expected value, so what you need to do is to use the grand total value and also the row total and column total. Okay, so the EIJ is found by taking row I total times the column J total divided by the grand total. So grand total tu yang mana? So kalau kita tengok yang kita punya gambar tadi, kita ada row and column. Okay, so kita ada yang ni row 1 total. So ini kita ada row 2 total. Here you have column 1 total. This one is column 2 total. So and then this will be the grand total. So itu yang dimaksudkan So which means that if you want to find the E over here, so this is E11. So E11 can be found by taking the row I total. So that means row row 1 total, and then multiply with column 1 total, and then divided by grand total. So you get the expected value for the first cells, and you repeat this for the rest of the cells. Okay, so it says here you have to calculate the expected frequency for each cells in the table. Since marginal will be unequal, in most cases you need formula 2 to compute the expected frequency. So you gunakan expected formula 2 to calculate expected frequency. Okay. Okay, next we look at where the chi-square test can be applied. So tadi saya dah terangkan di situasi mana kita boleh gunakan. So this the following are the situation where we can use the chi-square test again. So that just repeat whatever that we have done just now. So you can also use in testing if there is an association between gender and preferred learning method. Yang ni lebih kepada research kan. So if you want to see that preferred learning method, whether do male or female students prefer online or books. Okay, so kita nak tengok lah. So in this situation, you're going to see whether gender, the preference of learning method they depends on the gender of the students. Okay, so boleh buat itu Okay, that is one way. Maybe also you want to look at testing if there is an association between political ideology and opinion on tax reform. So dia ada dua kat situ kan. So satu political ideology. Okay, variable yang kedua adalah opinion on tax reform. So you can also apply chi-square test because both of these are nominal. Another one, you can also look into testing if there is an association between marital status and level of education. Okay, so nak tengok kat sini. So, adakah marital status depends on the level of education or not? Are they independent of level of education or not? Are those having a higher education being more single compared to married? Okay, for those yang ada contoh dia. So, and then boleh juga kita tengok marital status dengan gender. Right? Yeah. If you want to look at a three-way, boleh juga tengok marital status, gender, and level of education. Yang ni dia akan jadi three-way. Tapi kita tak masuk dalam syllabus kita lah yang tu Alright. So that is where you can apply, where you can use chi-square test as example of testing a hypothesis. Okay, how to write the hypothesis? Very simple. Okay, di sini saya bagi dua So dia ada kat situ. The first one you can just write variable 1 is independent of variable 2. So you can just replace the variable 1 and variable 2 with the respective variable under study. Okay. So you can just say first you can use the word independent. Always remember the null hypothesis is taking the term independent. So the alternative hypothesis will be variable 1 is not independent of variable 2. Or you can say variable 1 dependent of variable 2. Boleh juga So not independent dengan dependent boleh, tak ada masalah. Right? Or you can just use the word association. But of course in this case variable 1 is not associated. Dia terbalik. Jangan pula tengok yang bawah tu ada not independent. You pergi letak pula yang untuk yang kau gunakan perkataan association. Letak kat H1. Salah lah. Okay. So independent mean there is no association. So you have variable 1 is not associated with variable 2. Or you can say variable 1 is associated with variable 2. Okay. Okay, this is a working example. So saya akan tunjukkan working example for first working example. You can see in this situation. So suppose that the state legislature is considering a bill to lower the legal drinking age to 18. Okay, katakan ini kat overseas bukan kat Malaysia. So kalau kat Malaysia kita nak ban terus kan. Alright. Suppose that the state legislature is considering a bill to lower the legal drinking age to 18. A political scientist is interested in whether there is a relationship between party affiliation and attitude towards the bill. So nak tengok party affiliation dengan attitude towards the bill. A random sample of 150 registered Republicans and 200 registered Democrats are asked their opinion about the proposed bill. And this is the result that you have. So this is the output that you have. Okay. So let me just make it bigger so that you can see. Okay. Suppose that you have this thing. Okay. You have the political party, Republican and Democrats. And then you have the attitude towards the bill for, undecided or against them. And you can see that the row total, this is the join, the one in black is what we call as the joint values ataupun joint classification. For example, the 38 refer to a Republican who for or who said for ni the sokong who support for the legal drinking age bill to be lower to be set at 18 years old. Okay, so this is for the first joint classification. And then for the total over here, so all the total, the row total and the column total are the marginal values. Okay, and then you have 350 over here as the grand total. Okay, so that is the situation. So this is what we call as a contingency table or a bivariate table. And from this bivariate table, so the one in black, the value in black, this is what we call as the observed frequency. Okay, yang ni kita panggil sebagai observed frequency. So that means if you want to calculate the expected value for the first cell, Okay, okay, katakan kita nak okay, kita nak kira dia untuk sel ni ya. So for this cells, okay. Okay, let's say you want to find the okay, suppose that you want to find the cells over here. So let me just make it smaller balik. Okay, suppose that you want to find the expected value for cell number 1 here. So suppose that you want to find the one for here. What is the expected value? Again, if you look through back the example before the previous slides, to find the expected value, you have to use the row total and the column total, right? So in this case, the row total is 150. So you have to multiply with the column total, that is 130. And then divide by the 350, the grand total. So this will give you the expected value of 1. Okay, there. So this is shown in the solution. So you can see that to find the expected value of 1, you just simply multiply. Okay, multiply the value for the cells, that is 150 times 130, and then divided by the grand total. So the row total is 150 and the column total is 130 divided by the grand total. You get the expected value to be 55.7. Okay, so that's what you get for this one, 55.7. Okay, so yang ambil dua nilai ni, so row total, column total, multiply them and then divide by the 350, the grand total. Okay, and you have to do this for all the data. Okay, you have to do this for all the cells. So in this case, when you calculate for all cells, you get the expected value for the second cell is 15, for the third cell is 79.3, for the fourth cell 74.3, and then this one is 20, and then 105.7. Okay, remember in the earlier stage just now, so I mentioned that in order for the variables to be independent, the observed frequency and the expected frequency shouldn't be differ too much. If you can see here, I expected that there is a dependence between the particle affiliation with the attitude towards the bill. Okay, because you can see that some of the cells have a very large difference between the observed and the expected frequency. Okay, kalau tengok kat sini, some of it adalah agak besar juga. Ini memang kecil lah, 15 dengan 17 agak kecil. 18 and 20 will be smaller, right? But this one a bit large compared to the others. Okay, so I assume that it will have a dependent relationship. Okay. They are dependent. Okay, so let's look at the interpretation. If you calculate this one, so once you have the expected frequency, the next thing to do is to find the chi-square test of statistic. So in this situation, you can calculate the chi-square test of association by summing all the expected frequencies, the values for the observed minus expected frequency square divided by the expected frequency. Okay, so this is given by this table. So kalau perhatikan kat sini, so this is what you have, 38 minus 55.7 square divided. So this is actually yang tadi tu kan. So O minus E square divided by E. So you get the value over here to be 5.62, and do the same for the second cell, the third cell, fourth cell, fifth cell, and the sixth cells. So you get all these value and you sum all the values and you will get your chi-square values, that is 15.75. Okay, yang akan dapat kat sini 15.75. Okay, so what you need to do next is to compare this test value with the critical value obtained from the table. So the critical value obtained from the table is equal to 5.991. Okay, you get this from 5.991. So the degrees of freedom is 2 because you have 2 rows and 3 columns. So 2 minus 1 multiply with 3 minus 1. So you get 1 times 2, right? So 1 times 2. So this gives you 2. So the degrees of freedom is 2. Okay. So the degrees of freedom is 2. And then you find the critical value with alpha equal to 0.05. You get the value to be 5.991. Next, you have to compare. So in this situation, you are using chi-square test. So the chi-square test is similar to the F-test. So you have 5.911 over here. And then you have the test value 15.75 over here. So this will be the rejection region. So right now your test value is in the rejection region. So that means you reject H0. Okay, so that's why it says here, using an alpha of 0.05, the critical value from table would be 5.991. Since our calculated chi-square is 15.75, we conclude that there is a relationship between political party and opinion on lowering the drinking age, thereby rejecting the null hypothesis. So we reject the null hypothesis. Null hypothesis kita apa tadi? They are independent, right? So bila kita reject, that means they are dependent. So that's why kita kata kat sini there is a relationship. Okay, so that is for the working example number 1. Okay, this is another example. You can go through this one later on. So let me just get the information. For example, in this case, in the sample data set, respondents were asked their gender and whether or not they were a cigarette smoker. So kita nak tengok the relationship between gender and cigarette smoker. Do gender play a role in deciding whether they are smoker or not? Okay. So there were 3 answer choices: non-smoker, past smoker, and current smoker. Suppose we want to test for an association between smoking behavior, whether it is non-smoker, smoker, current smoker, or past smoker, and gender, male or female. So we want to use the chi-square test of independence. We'll use alpha equals 0.05. So in this situation, the hypothesis can be written as gender is not associated with smoking against gender is associated with smoking. Or the other way around, smoking is not associated with gender, smoking is associated with gender. Boleh juga, tak ada masalah. Okay, so this statement can be done using, if you have a large data set, that means you have to use a statistical software to solve the problems. So what you need to do is just simply run the software. So before you run the software, one thing that is best for you to perform is to visualize the data itself. Okay, this can be done by looking at a cluster bar chart. So kalau you perhatikan dekat sini, okay, based on the cluster bar chart here, you can see that within the smoking habit, is there much difference between male and female? Ada banyak beza tak? Kalau you perhatikan kat sini, untuk non-smoker, the height of the bar is almost the same, right? Similarly, for the past smoker, it doesn't show much difference. And also for the current smoker, it doesn't show also much different in terms of the data being visualized using cluster bar chart. So kalau tengok kat sini, memang saya pastikan the situation maybe it will give you the answers to be not associated because the difference between the two categories doesn't show much difference. The difference is not too large. Kau tengok yang non-smoker almost the same. Untuk yang current smoker pun almost the same. Cuma yang past smoker ni dia dah besar sikit. Tapi still it is being mirrored by the two yang no difference here. Okay. So that is one way to identify whether there is a association or not. Okay, biasanya kita boleh tengok dari sini dululah. Okay, it is the graph here is explained over here, so you can just read this through later on, and then you can see for the running the test. Okay, how to run the test in SPSS. If you want to run the test for SPSS, you have two variables just now. So one is the there are two ways to run the test in SPSS. One is for the raw data set, and the second one is using the frequency count. If you have a table of contingency table and you want to transform this into an SPSS, then you have the frequency distribution. Okay, you have the frequency for each of the categories. But if you are running using a raw data set, so this is the way how you have to run. Okay, so you akan ada dua kolom saja lah. Kalau katakan gunakan contingency table tadi, you akan ada tiga kolom First column will be your first variable, the second column will be the second variable, the third column will be the frequency. But if you are using the raw data set, you only have two columns, first variable dengan second variable, itu je. Okay. Alright. So you open the cross tab dialogs and then you click on Analyze, Descriptive, Statistic and Cross tab. So untuk dapatkan cross tab dialogs, kita pergi pada Analyze, Descriptive, Statistic and Cross tab. So you will try this on your own. And then the second one, you have to select smoking as the row variable. Okay, put the select smoking at the row variable and gender in the column variable. And then click Statistic. So under the statistic, you choose chi-square. And then click Continue. And then you have optional, check the box for display for cluster bar chart. And for option, actually ada satu lagi. So in this case, saya tak buat yang tu. So you can also get the expected value from the software. So in order to do that, you need to go for options in the dialog box. So under option, you check on expected. Okay, dia ada dua. Satu observe, satu lagi expected. So yang ni check by default. Okay, but for the expected, it will be checked by request. Kalau you pengguna request nak expected, dia akan kena check mark lah that particular information. Baru dia akan keluarkan dia punya expected value. Okay, if you have done that, so click statistic, check the chi-square, click continue, and then check the box for display cluster bar chart. Kalau kita nak tengok yang bar chart yang tadi, kita click the cluster bar chart. And then last kali, click OK, and then you will get the result. Okay, if you click on the cluster bar chart, you will get this cluster bar chart at the first place. Okay, if you don't click, you don't get that bar chart. And then once you click OK, you will get the result. So this is the syntax. Kalau untuk gunakan those yang expert guna syntax dalam SPSS, this will be the syntax. So yang ni kita skip dulu. Okay, so under the test, chi-square test, you will have three main table. So the first table is the case processing summary, which tell us the number of valid cases used for analysis. Only cases with non-missing values for both smoking behavior and gender can be used in the test. Okay. And then the second and third table give you the cross tabulation and the chi-square test result. So this is shown in the next step, where you have the table 1 for the case processing summary, and then you have the cross tabulation and the chi-square test. So this is the tables looks like. Okay, this is for the case processing summary, the table 1. Okay, so you have the smoking and gender, you have the valid cases 402, the missing you have 33. So in this case ada missing. Kalau tak ada missing, dia kena dah tak ada missing. Alright, so this is the case summary. And then the second one will be the cross tabulation. So this is the contingency table. If you check on the expected frequency, it will show expected frequency at the bottom over here. Below each of the observed value, you will see the expected frequency. Okay. And then the third one give you the chi-square test result. So what you are interested in for this under this syllabus is to look for the Pearson chi-square. So this is the test value. If you calculate the test value, you should get 3.171. And of course, to find the critical value, you have to find it through the statistical table. Here you have the degrees of freedom. You know that for degrees of freedom 2 with alpha level 0.05, the critical value is 5.991. Okay, tadi kita kira kan? So it is greater than the test value. So you fail to reject. So in this case, you will reject the null hypothesis if this value is less than 0.05. However, you should note that this value is given in the form of two-sided. And you know that chi-square test is a one-sided distribution. So that means you have to divide this by 2 in order to get the correct value. So divide this by 2, you get 0.1025. Okay, 0.1025, which is still also less than greater than 0.05. So in this situation, you fail to reject the null hypothesis. As what I illustrated the now, okay, macam saya katakan tadi, kalau kita based on the cluster bar chart, you can see that there is no significant difference, right? There is no association. So in this situation, you fail to reject the null hypothesis, meaning to say that there is no association between the two groups. Okay. Alright. So that is the table. And this is the key important result that you get from the table. So the key result in the chi-square test is under the Pearson chi-square. The value of the test is 3.171. If you calculated this manually, you should get the same value. Okay, the footnote for this statistic pertains to the expected cell count. So this is the assumption. Remember, assumption expected frequency shouldn't be less than 5 for more than 20%, right? So kat sini tak ada so dia ada no cells. So kalau you tengok balik kat sini, kat bawah ni dia katakan 0 cells expected frequency. Okay, says here 0 cells have expected count less than 5. So you do not violate the assumption. Okay. And then you have the degrees of freedom yang redundant, nanti saya buang tu lagi. 2, and then the corresponding p-value is 0.0205 for two-sided. Okay, so these are the key values or key information result that you get from the output. And for your decision, so you can say that since the p-value is greater than our chosen significant level alpha 0.05, we do not reject the null hypothesis. Rather, we conclude that there is not enough evidence to suggest an association between gender and smoking. So based on the result, we can state the following. No association was found between gender and smoking behavior. where the chi-square test value is given by 3.171 and the p-value is 0.205. Okay, so that is for the second example, and this is the past semester exam papers, and we will do this later on. Okay, you can just see how they present the data to you when they deal with in the exam, final exam. So this is the things that you can see. So they give you the contingency table together with the count and the expected count, and some of the values they make it missing. So contohnya kat sini expected count kat ni dia katakan A. So you kena carilah apakah nilai A tu. So you know that 17 plus A equal to 34. So that means to get the value of A, just simply take 34 minus 17. So you should get the value of A. Or you can just go row wise. So 50 minus 25 minus 8, you get the value for A. Same thing. Okay. So